Hello, class. Today we're going to be talking about special right triangles. So the first triangle I want to talk about is the pi over 4, pi over 4, pi over 2 triangle. So these are going to be angles within our triangle. And remember, both of these triangles are going to have a right angle in it, so they're going to have pi over 2 in it. So this is also called the isosceles right triangle, because having two of the same angle means that we're going to have two equal sides. So we're going to have the right angle, and these are going to be our pi over 4 angles right here. The side lengths of these angles are going to be A, and A square root of 2. This A is just a variable. So this is just a variable. If we have a triangle with one of the legs with side 5, then the hypotenuse is size 5 square root of 2, because A is just a variable. So I want to make that clear. Another name we can give this triangle is a name by lengths. So you might see something written like this. And this is just naming this triangle. And that's basically it for the special right triangle. This is really good to remember and memorize because it shows up a lot in trigonometry, and it'll be helpful once we go over trig functions. Okay, so what's the second triangle that we're going to talk about? Well, again, it's going to be a special right triangle. So there's going to be a pi over 2 in it. The other two angles are going to be pi over 6 and pi over 3. So what does this triangle look like? Well, it looks something like this. So it has kind of like a sharper peak. So this right here is going to be our right triangle. This is going to be our pi over 3 angle, sorry. And this is going to be our pi over 6 angle. So these measurements are going to be A over 2 and square root 3A over 2. So again, A is just a variable. If we have, let's write this on the side. If we have A equal to 4, sorry, excuse me, then this will simply be square root of 3 times 2, and this would be 2. So again, A is just some value. We can set it to be whatever it is. And then in certain triangles, if you're given one of these sides, you can backward solve for A, and then you can solve for the entire triangle. So let me give you an example of backward solving for A using these triangles. Okay. Alright, so first we can look at one of the 45, 45, 90 triangles. I probably shouldn't have said that. We want to talk about these triangles in radians. So the 45, 45, 90 triangle you may be used to is now the pi over 2, pi over 4, pi over 4 triangle. It's a lot more of a mouthful, but try to keep that in mind. We're trying to focus on radians and not degrees. Okay, so if we have a triangle like this, we have a 90-degree angle, and we know that this angle is pi over 4. If I tell you that this side right here is square root of 5, how do you solve for the other two sides? Well, in this triangle, we know that this number right here is equal to square root of 2 times A. So we can take this and we can solve for A. All we do is divide by square root of 2. So here A is going to be equal to the square root of 5 over 2. And that's all we needed to do to solve for these sides. So this side is going to be square root of 5 over 2. and this side is equally going to be square root of 5 over 2. And for our pi over 4, the right isosceles triangle, this is all you need to do. You just need to backward solve for a and plug it into your other sides. Alright, so let's look at our other triangle. So this is going to be the pi over 6, pi over 3 triangle. So this is going to be pi over 3. And let's say that this side is square root of 3 over 2. So from our definition, we know that this is equal to a over 2. So that tells us that a is equal to square root of 3. And from this, we can backward solve this. So this is square root of 3 over 2 times a. So that means that this side is equal to 3 over 2, because 3 over 2 is equal to square root of 3 times square root of 3 over 2. And using this a as well, we know that this side is simply a, so that means that this side is equal to just square root of 3. And again, that's all. So whenever you're using the special right triangles to solve for the side lengths of the triangles, all you do is backward solve for a and plug a into all of your relationships. And that's it for this video. So I hope this cleared things up. Hope you all have a good one, and I'll see you next time.